Okay, so good evening everyone. Today is our lecture 2 of the TA session for Algebra 2. So, based on the syllabus uh, that is group action, quotients, group homomorphism, normal subgroup, quotient group, uh, product and Chinese remainder theorem, dihedral. So, various things are there, but I don't know if I can cover everything. So I have prepared a set of problems. So I'll try to cover everything, but if I don't, uh, I'll try to cover the remaining parts in the next lecture. So okay, uh, let's start with lecture 2. Now, okay. So let us start with okay. So I hope you know by now what is a order of a group. Uh, so start with this one. Question 1, that is, if in the group G, given that a to the power 5 equals to E and AB A inverse equals to B square for some AB belongs to G, uh, okay, I will tell, first write me this, find order of B. So this is a pretty simple calculative question. I'm giving this one because I'm expecting you have learned things by now from the first lecture. So yeah, Shankaran, I'll be taking a 6 p.m. class every Tuesday. If uh, if something if something happens, or if I change the date and time, I think yeah, you will be notified by NPTEL. But yeah, this will be the normal time. Okay. So I'm expecting you will be trying this for 1 or 2 minutes or giving me hints. Uh, Okay, so let's start solving this. uh, Solution. uh, Given uh, a square b minus 2 should be a into ab, a inverse of a inverse, and you are given that ab, a inverse is b square, so we'll replace this by a b square, a inverse. So it can be again written as a b, a inverse, because this is e, so b, a inverse. Better to write it as this. uh, this should be a and this should be a inverse, yeah. Then you can then these two terms are identical, so uh, sorry, so we take the square, and it should be b square of whole square, and that is b to the power 4. So now now we can uh, take induction on n. So for n equals to 2, we have shown a square b inverse should be b to the power 4. It can be for general n.
Excuse me, sir.
Yeah.
So how did you write the step in second line? The first step in second line. A dot B dot A inverse dot A dot B dot A inverse.
Oh, how did I write this?
Yes, sir.
Because okay, let me be more specific. From here I can write this, right? Right?
Yes, sir.
And from here, now you see that I,
Okay, 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 sir. I
yeah, yeah,
got it. I got it
this is
now.
just E, yeah,
Okay, thank you, sir.
yeah. So now for general n, uh, again it can be shown that it can be shown that uh, that a to the power n, b, a to the power minus n should be b to the power 2 to the power n. I mean, this is just b to the power 2 square, and if you just follow this simple process, again you will get that this, or say I am proving this. Now for induction I have proved the base case, that is n equals to 2. I am assuming that for general n this is true. Now for n plus 1, say a to the power n plus 1 dot b dot a to the power minus of n plus 1, this should be equals to a into a to the power n, b into a to the power minus n into a inverse, right? Now from induction, and for the nth case we can replace this by b into 2 to the power n A inverse. So that means using uh, this process again from here to here, we can simply say this, that this means A B A inverse dot A B A inverse up to A B A inverse, that is the transfer, say 2 to the power n times. So that means uh, this is nothing but A dot A inverse 2 to the power n, and again AB inverse from here, it is nothing but B square, and we have 2 to the power n, so it should be B into 2 into 2 to the power n, that means B into 2 to the power n plus 1. So hence we have proven a to the power n b a to the power minus n should be b to the power 2n for any n belongs to n. Because, is it true for belongs to z? That might be a little trickier, but I encourage you to try this for yourself. So my now let's take let's take n equals to 5, then b to the power 2 to the power 5 equals to a to the power 5 b to the power minus 5, and given that a to the power 5 equals to e, we can simply replace this by e b e, that is b. So that means we have b to the power 2 to the power 5 minus 1 equals to e, and that means b to the power 31 equals to e. So now like if I don't know if you have proven this or not, that if b to the power okay, I just put it as a small remark, if b to the power m equals to e for some positive m, so I just write it in natural numbers, then order of b divides m. So 31 is a prime number, right? So okay, let me just highlight this. So we have order of b equals to 1 or 31. So what we have shown that if in the group G we have a to the power 5 equals to identity, and AB inverse equals to b square, for some AB belongs to G, then order of B equals to either 31 or 1. So please let me know if you have any doubt from this solution. Okay, let me just prove the remark that I have just uh, shown. uh, okay, proof of the remark, that is question number 2. So mm, what I have written is that if b to the power m equals to e for some m belongs to n, then order of b divides m. Now uh, okay, there are integers I and j from z such that m equals to I of order of b plus j, right? This is like the division algorithm of z, that for any two integers you can get two integers such that you can write in this form. So it will basically you will be formally introduced to this in ring theory. I think this is pretty standard from 11th and 12th, because you can just simply divide this one number to other. I mean, you can just divide m to ob and like ob uh, divides m, and if it does not divide, then you get some residue, and from there you can write this. So but this is much more general result for a integral domain or Euclidean domain, but those will come later. uh, but the motivations, all these things come from the integer and the rational numbers. Okay, there are integers I j from z such that this and 0, I mean j runs from 0 to less than order of a. Now we have e equals to uh, a to the power n, that is, sorry, b to the power n should be b. So that means what? That it should be b to the power I uh, order of b plus j. So this means that b to the power order of b to the power I into b to the power j. So this means that e to the power I into b to the power j, that is b to the power j. So now if j not equals to 0, and given that j less than order of b, so this means that b to the power j not equals to e, right? Follows from definition of order of b, right? That is that order of b means what? That the ob is the least positive integer such that b to the power ob equals to e. So j is strictly less than ob means that b to the power j cannot be e. So we have j equals to 0, that is m equals to I of order of b. This implies that order of b divides m. So yeah, we have successfully found the order of b, and also the claim we used in the proof, we also successfully proved that. Now we come to our next problem. So maybe we can do some normal subgroup problems, because uh, uh, the quotient groups and uh, most of the important things like the counting problem and everything, uh, they will follow from these normal subgroups. Okay, so first let's start with an easy one. If H is a subgroup of G such that, by the way, I am following exercises from Harstein's Harstein's topics in algebra. So those who are missing something from my lectures, you can tell me, and later you can check Harstein's book. It's a quite compact books and readable also. Okay, if H is a subgroup of G such that the product of two right cosets of H in G, again a right coset of H in G, prove that H is normal in G. So right cosets usually look like this. So you can just so what I'm telling you, that product of two right cosets, that means in the usual notion that uh, some form, then you should show that H is normal in G. And one of the ways to show that H is normal in G is that G inverse should be H for all G belongs to G. So yeah, you can just think for 1 to 2 minutes and let me know. Like in usual sense that H of G1 dot H of G2 should be H of G1 G2. I mean, this is the like natural intuition, right? And we follow that intuition only, that one has to show that this product is well defined. uh, no, like, uh, you have to use this thing that we are assuming that this should be the case, that the product of two right quotients is again a right quotient. Like, it is not always possible that it is a the product of two right quotients is a right quotient. For example, if you take any subgroup which is not normal, then you will see that this jump over thing, because if you take hg1 dot hg2, if g1 does not jump to g2, jump to this side, then showing that h is normal is not possible. So for this case we are assuming that this is happening, that yeah, I mean in the question it should be mentioned how the product is defined. So you can just, yeah, I get your point that is again a right quotient, and the the operation should be hg1 dot hg2 equals to hg1 g2 for all g1 g2 coming from g. Yeah, now I think it's fine. Okay, so let's do this solution. Now for every g belongs to g, hg of hg inverse is a right quotient in g by our assumption so since E equals to E dot G, E G inverse, and you can see that this part belongs to HG, and this part belongs to HG inverse, so they belongs to HG inverse. Actually this is not needed, I don't have to define this, I'll come to it later. uh, so uh, this is, no, what am I saying, sorry. Let's keep this, we should define the operation. Okay, then it should be h of g inverse, that is he, that is h. So we have shown that this, hence for all small h to h we have g inverse equals to eg h g inverse belongs to hg inverse, right? Because again eg belongs to hg, and small h g inverse belongs to capital H g inverse. So yeah, this is again h, So what we have shown that uh, for all h belongs to h, and uh, for every g belongs to g, it should be that small g h g inverse belongs to h. That is uh, we have gh g inverse belongs to h for every g belongs to g. So we are done. Okay, why is this again h if you do not define the operation, and also the operation is well defined when h is normal. Actually, you know what, that the fact is that you have to do. I know there is some fishy in this problem for me too, but since I have written down this, and uh, I mean, we are just defining it this way, like that it is given that if H is a subgroup of G such that the product of two right cosets of H in G, again a right coset of H in G, uh, if this condition is given, then we have to prove that H is normal in G. So in order to prove H is normal, we are assuming that this condition is true, and only way to assume that this condition is true, that we should take this operation as this, like but again this is true that when you define an operation it should be well defined, but yeah, and it is true that this is well defined only, again, yeah, it can be shown like that yeah, you are right. But in order to do this thing, we need exactly this. No, we are not using this, that h g dashed should not be h, that we are not using. uh, what I have written, that if you look carefully, hg1 hg2 should be hg1 g2, not not h, and it cannot be some hc in last statement. You mean this? You mean this? This? Oh, this you are saying. Here? Oh, but uh, from here it follows, na? the way we define the product, and from there it simply follows that Hg inverse should be H. Okay, for now let's leave it. uh, you have you have said a good point that uh, that the product of two right cosets should be defined here. But anyway, okay, let's leave it for now. And we move to the next problem. Uh,
Sir,
yeah,
sir, you are using the definition of the product here.
yeah, yeah,
So it is well defined when H is normal. So
yeah,
it
yeah,
is
I know,
already normal. So what you are proving?
I know that this is only well defined when H is normal.
Yes.
But the
Sir, my point is that it is saying that product of two right cosets is a right coset. So we do not use the definition of the product. We can use like HA, HB is equal to HC some for some C.
okay, yeah,
Hmm.
okay, you are saying that if I just take here G3, uh,
Yes, sir. For some G3
huh,
belongs to the.
for some G1, G2, and G3 belongs to G,
Yes, sir.
then from here you can show that this should be uh, AG dashed. uh, E belongs to okay, let's leave it for now, because it would waste time for me to think it and do it. Maybe I will solve this and send you by email. uh, but yeah, you are right, we cannot use that hg1 hg2 equals to hg1 g2, because that would simply mean the well definedness of, I mean, that would simply mean that H is normal. But anyway, okay, thank you for this point, Sandeep. I will keep in mind. Okay, so let's go to our next problem. Uh, that is problem 4. Then this one is also uh, like interesting. If G is a group and H is a subgroup of index 2 in G, prove that H is a normal subgroup in G. Okay, try this and I'll look into the previous problem.
Sir,
Yeah,
sir, two right cosets are either disjoint or they are equal. This
yeah.
is true. So here we see that E belongs to Hg inverse,
Hmm.
and E also belongs to H.
Okay.
So Hg inverse must be equal to H.
Yeah. So
Yes,
that means
so
H is normal.
you can, yes, so you can use this. No, sir, I am telling for the third one.
Okay.
I am
S
sir telling for the third question.
Sorry.
The previous question, sir.
Yeah.
Sir, you have used here na Hg inverse is H.
Huh.
So I am telling that this is true, and we can proceed like since E belongs to Hg inverse, and E belongs to also H. So two right cosets are either disjoint or they are equal. Since E belongs to both, so Hg inverse must be H.
Sorry. Can you tell me again?
Sir, E belongs to Hg inverse.
Yeah.
You have written here,
Yeah. That we have
and
done.
E also belongs to He.
Also belongs to He.
Yes, sir. So we have a
Ah.
theorem
Yeah.
that
Yeah. Yeah. You
they
are
form a
right.
partition.
You are right. You are
So
right.
yes, sir. So you have good
Yeah. Yeah.
proof. But
It
you
should
should mention this.
it should come to me. Yeah. Yeah. You are right. So what he is saying that I completely forgot this argument. That is why I was like it was keep getting messed up in my head. Okay, so we have done that. E belongs to Hg dashed for some. Thank you, Sandeep, by the way, for saving my time and saving everyone else's time.
Yes.
Yeah, E belongs to Hg dashed, and let me just. So, and we have E belongs to Hg, that is Hg dashed. Hg is at least E belongs to, that is non-empty, so Hg dashed equals to Hg equals to H. Yeah, from here we can proceed that this also follows for, yeah, Hg dashed equals to H. Yeah, thank you. Now what he just said, I will formally write this thing, uh, this index thing. So there are exactly two right cosets H and Hg of H in G and two left cosets H and GH of H in G. Therefore, the right coset Hg equals to GH is also a left coset. Again, using the previous argument that either they are equal or they have empty intersection of H. So yeah, this is also an equivalent definition of normality of H. So H is normal in G. Now we go to our next problem.
Sir,
Yeah.
so why this G must be same?
Oh, this one.
You have written that two right cosets H and HG, and you have written two left cosets H and GH. So I want to ask that why both G are same. They may be different like G dash H. Why here G you have taken same? It can
Like
form.
yeah, you can take defined G dashed, but they will mean same, right? Because uh, I mean if I take uh, G and G dashed, then
Hmm.
say that G dashed H equals to HG, sorry, there are exactly two right cosets HG of H in G, and say two left cosets H and G dashed H of H in G. Therefore, the right coset.
So then G dash H will become equal to GH only, since there are only two left cosets.
Yeah, can you
So
can you tell me again?
I'm saying that G dash H
Yeah,
will be equal to GH only, since there are only two left cosets.
yeah,
It won't make any difference if we take G dash or
yeah, yeah,
G.
yeah, yeah. Like there are only two cosets, right? Either G dashed, sorry, G dashed H equals to H or GH, right? So since we are taking already Hg to be like not equals to H, because if uh, H equals to Hg, then there should be another G prime, G should be E, and this implies that G double prime E. That means sorry, you can write it as H, and since inverse is unique, so you can put H. That would simply mean that G of H equals to H, but this is not the case, right? So uh, thank you, who just said I did not see your name. Now is it clear?
So first we need to show that this G must be same. Then we can state this
Yeah, I mean
because hmm,
you since if both the both you and me, if we are both clear, then then you can avoid these little trivial things. When I prepared these notes, I just simply avoided those things. But
and
anyway,
therefore the right coset Hg is equal to Gh.
yeah, yeah, yeah.
Hg is equal to Gh. How are you getting this equality?
First, you tell me that this thing is clear. That your first question, what you just said.
Yes, sir.
Yeah. Okay. So now, again, I think from the similar argument you will get this, that if Hg equals to, I mean, what I have just showed that Hg not equals to H, right? If I go back, sorry, Yeah, if this was the case, then you would get this. So gh not equals to h, right? And you have taken this also. Are you getting this? That we have just shown that hg not equals to h. So h is already a one of two cosets here. So only way is uh, you are getting this is that if they are not equal, then
Excuse me, sir.
yeah.
Can you please explain these 2 to 3 steps written here in the right corner?
Okay, I should write this formally. Okay, give me 1 minute and I write this formally. I should be more careful when I write these things. So first, if this is clear that there are only two left cosets and two right cosets are there, then you know that the left cosets and right cosets are either disjoint and same, right? So g equals to, here you have hg, and again here you have gh. So from set theoretic approach, this implies this, na, hg equals to gh, because uh, these are disjoint unions, so the elements get separated, and you just, this means what, that g minus h equals to hg, and from here again this implies that uh, g minus h is gh. Does this make sense?
Yes, sir.
Right? uh, I don't know who asked.
Yes, sir.
Yeah, yeah. Okay, but this is good. You are involving in this process and I should be more careful. Usually I am alone speaking for last 2 semesters, so yeah. I should be more careful when I speak from the second time. Okay, okay. Let's solve this. Okay, last time I think I said that we would do some matrix problems. So group homomorphism and automorphism has not been done yet, right?
Excuse me, sir.
Uh, Group homomorphism and group automorphism, like injective morphism, surjective morphism, those has not been done yet, right?
Sir, I want to ask. I did not attend the last lecture, so is
Ah,
there any recording available for the lecture one?
in lecture one it was not there. Monomorphism has done. So they should have done epimorphism also. But anyway,
I think it was there in week one. In the last few pages, it was there, and this week definitely they have done it in detail, like week two.
Okay, okay, thank you.
okay, okay, okay. Then okay, fine. We should do some at least matrix problems because they are also important. Okay, let's start with this one. Let G be the set of all real 2 cos 2 matrices A B 0 D, where AD not equals to 0. Prove that G is a group under matrix multiplication. And another question, is G abelian? The first part is routine, right? Like you don't have to, you just find your identity element, that is 1 1, I mean diagonal 1 1 and 0 0, that is identity. And just you take the inverse of this matrix, then you are done. So first part you can leave it. The only challenge is to, not challenge, only problem is to show that it is abelian or not. So can you find any counter example, or in general if you could show that
Sir,
Yeah.
take two matrices as 1100 and 0100.
So 1100.
0100.
Okay.
You will get 0100
Yeah.
and this will give you zero matrix.
So this matrix does not belong to G.
Sorry.
Ah, yes, yes, yes. Yes, these matrices do not belong to
Yeah.
the given.
I
Yeah.
have a counterexample.
Nice observation. Okay. So uh, they do not belongs to G.
Should I say it?
Yeah.
My
Yeah.
counterexample.
Yeah. Yeah. You say it.
So 1202
Okay.
and 1305.
05.
Yes, sir.
Okay. So it should be 1,
1,
13,
0, 10.
0, and 10. 1305, 202, 1,
It's 1,
8, 0,
0, 10.
10. Yeah. So this is good. Yeah. Thank you. I should know your name. Uh,
So it's Akansha.
okay. Thank you, Akansha.
You're
Okay.
welcome.
Uh, okay. Let's go to our next problem then. Uh, 6, that is let G be a group in which for some integer n greater than 1 we have ab to the power n equals to a n bn for all ab belongs to G, so that this is a two-part question. uh, for a power n equals to x to the power n which belongs to G is a normal subgroup and for B power n minus 1 x to the power n minus 1 which belongs to G is a subgroup G normal subgroup G. So note that this is not for all integer, this is for some integer. So there is no confusion between a and b. One might think that they are similar but they are not. Okay, so let's try this. Let me know. So first you have to show that they are subgroup, but this is clear the uh, from the given assumption, that is this from this you can see that this is closed at least, and other things follow subsequently because e to the power n equals to e, that is there. And if you take a inverse for a, and a inverse to the power n equals to a to the power minus n, so that is also there.
Sir, in part A, n is fixed.
N is, yeah, you can consider n is fixed.
So can you please repeat how it will form a subgroup?
Okay,
A part.
yeah, I will. Solution. So this is the given condition, right? So from here you can see that sorry, Gn is closed under multiplication, right? From the given condition nbn equals to abn. This is clear, right?
Sir,
Yes, sir.
for
Yeah,
some n it is given.
sorry.
Sir, it is given for some n, not n is fixed.
uh, like for some means there is at least one n, right?
Yes, sir.
So yeah, so it is
So
n.
how can you say that this is the that n?
This is the,
This is that n, specific that n for a b to
like,
the power n is
no no
equal to
no,
a to the
yeah,
power
you just
n.
suppose say that for some n means I say n1 n2 something like this.
Uh,
So you just choose a random ni, label this as n, and so it is enough to show this for n, right? So if you, because this was arbitrary, so we have shown for any of the
sir,
cases.
but here, sir, g to the power n is fixed, na here.
Yeah, like when you
This is
fix
small
one,
n is fixed here. So how can you claim that for these AB, this is that n for the AB power n is equal to a to the power n into b to the power n.
see, for one thing that uh, if this is true for like one, like for one n, then uh, for 2n, like it would be a to the power 2n, it should be uh, ab to the power n and the power n, so an bn n bn, but it does not say about the commutativity. So see, the question is simple, that if it is true for some n,
Yes,
then
sir.
you have to show that uh, these are normal subgroups. So what I am trying to say is that let's not focus on some this, you just take a integer from these given choices and show these are normal. So what you have done that for any of the integer coming from satisfying these conditions, they have these,
Okay.
right?
So that is the integer which satisfies this
Yeah,
condition.
yeah, yeah.
So this is not a random n.
No, 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 this is not random, obviously. No, 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 no.
Yes, so
Okay,
that is the conclusion.
let's get back to your question, Akanksha. So Gn is closed under multiplication, that is clear from the given condition. Now e equals to e to the power n, so this belongs to Gn. So again this is also true, that e belongs to this. uh,
Identity also belongs.
yeah, identity also there. Now a inverse belongs to G. This implies that a inverse to the power n belongs to this. That implies a to the power minus n belongs to Gn. So uh, yeah, a was arbitrary. So for for an belongs to Gn, we have a minus n belongs to Gn, right? So we have also inverse there.
Yes, sir.
And the associative part you can do this yourself, right?
Okay, sir. I will try.
Yeah, yeah. And let me know if you get stuck, then we'll do this together. Okay.
Okay.
So associativity follow from the group itself.
Yeah, actually, let's do this. An
Yes, sir.
B
Actually, decided to.
Cn.
Associative is on true.
Yeah.
Yeah.
Oh, you will try?
Okay, sir. I will try and let you know.
Yeah, yeah, yeah. Also, just this is this, and let's take these as two elements from the group. Then again, these satisfy A, B, C, N, and then you apply associativity here, and then yeah,
Okay, sir. I got it.
yeah, yeah. So okay, now let's show that A is normal, but uh, this is quite trivial because for G belongs to G and Xn belongs to Gn, we have G Xn G inverse. Uh, Again, if you just use that Gx G inverse G X G inverse G and do this up to G inverse G X G inverse, and so like this, these are happening n times. Then you will see that Gx G inverse is repeating n times, and again Gx G inverse belongs to G, so this belongs to G to the power G to the power first bracket n. So what you have shown that G Gn G inverse belongs to Gn for all G belongs to G, so Gn is normal. Clear, right? Now the second part, that is part B, that Gn minus 1 is normal in G. Can anyone think and tell me? We have to use a little trick, but uh, that is not that bad. So if any one of you can think and tell me. First we have to show that it is a subgroup, and to show that it is a subgroup, The only tricky part is that it is closed under multiplication. Okay. Okay, take your time, and I'm taking a break for 2 minutes, and I'm coming back.
Sir, can't you just replace n by n minus 1?
Sorry.
Sir, can't we just replace n by n minus 1?
Or replace n by n minus 1.
Yes, sir.
But say I am like the my previous talk with Sandeep. Say we just take single n. We just assume that for single n this is possible. So for n minus 1 this is not possible, right?
Okay, okay, sir.
Yeah. So actually there is a trick, that is that it actually follows from this. We have abn equals to an bn, a to the power n, b to the power n, and from here it follows that ab times ab times ab up to n times, it equals to an bn. So if you just take a inverse and
By
ab,
cancellation. Yes.
yeah, ab, and here you take b inverse, then it should be a inverse an bn and n, sorry, b inverse. So what we have done is that b times ab dot a, where this runs for n minus 2 times, equals to a to the power n minus 1 to b to the power n minus 1. But you see that it can be rewritten as b to the power a to b to the power sorry, b dot a up to n minus 1 times, right? This part is crucial for what I will claim. Is it clear? So there are already n minus 2 two tuples and this one. So you see that like numerically I am right that there are actually 2 into n minus 2 plus 2 terms. So this means that 2 into n minus 1 terms. So yeah, you can check it, but this is trivial, like you can check it. So this will imply that b dot a to the power n minus 1 n minus 1 b to the power n minus 1, and b to the b dot a belongs to uh, g. This implies that b dot a to the power n minus 1 belongs to g to the power minus 1. So this is one thing is clear, that this is closed under multiplication. And then again this inverse thing and the associativity and the identity thing follows, and showing that it is normal again follows from the previous uh, uh, argument, that for g belongs to g and y to the power n minus 1 belongs to g n minus 1, we have g y to the power n minus 1 g inverse, and this will simply imply that gy g inverse of n minus 1, and this belongs to g n minus 1, right? So is normal. So main challenge in this whole problem was only to show that g to the power first bracket n minus 1 is a subgroup.
Sure.
Yeah,
So, by the principle of mathematical induction, can we show that this is true for all n minus k, where k is less than n?
this is true for all
N minus k, like g to the power n minus k is normal for all k less than
n.
n.
Okay, you are saying that if we gradually go downwards, you can show
Like
that.
gn minus 1, gn minus 2, gn minus 3, and so on.
Yeah, because
Because, sir, for n is equal to 1, it is true.
yeah,
And we have shown for n minus 1, ba to the power n minus 1 is an minus uh,
but
bn
I
minus
think you will face one problem, that for you are saying that we have to go downwards successively. So for from n to n minus 1, this is clear because we have that ab to the power n equals to an dot bn, right? But for the n minus 1 case, we get uh, this
yes, sir, order is changed.
order changed. So from this to get n minus 2 case, I think it would create some complication. I'm saying no, not no, that, but it may create some complication. But yeah, this is like curious observation. So kudos to that, and you can try. If this is case, maybe this will be good.
Sir, there is no base case actually. If we take n is equal to n, so we'll be getting ab is equal to ab. But here the order is changed. So
Yeah.
I think
Mm-hmm.
for some k this may be true, but not for all k.
Yeah, yeah. And also it is given that the integer we take should be greater than 1. Integer is given is greater than 1, not we
Yes,
take.
sir.
Yeah, yeah. Okay. So we go to our next problem. Uh, so it was question 6, question 7. That is okay. Uh, let us do some do some problem follows from the previous problem. Let g be same as the previous problem, that is there for all AB belongs to G, we have a, AB to the power n equals to an bn for some n greater than 1. Then show that I think this came in a TIFR or something entrance test. So for all belongs to G, and the second part is yeah, AB A inverse B inverse into n into n minus 1 A for all AB belongs to G. Maybe you can try with some cancellation and with all those things we have done.
The first part is done.
Yeah,
Yes, the first part is done.
actually I
I proved that first part. Should I share?
yeah, you can share.
That I have written a raised to power n,
Yeah.
b raised to power n
Hmm.
is equal to ab into ab n times.
Hmm.
Then on the left side, I
Hmm.
have applied a inverse.
Hmm.
Then left side will become a raised to power n minus 1 b raised to power n is
Yeah.
equal and the right side will be b dot ab into ab n minus 1 times.
Yeah.
And in the last question, in the b part,
Yeah.
we have been ba power n minus 1 is equal to a raised to power n minus 1 b raised to power n minus 1.
Hmm.
I have used that in the right hand side.
Yeah.
That a b raised to power n minus 1 will become to b raised to power n minus 1 a raised to power n minus 1.
Actually, yeah, you have to use this thing that successively.
Yes, sir, this one and the b part, last question b part.
Yeah, like 7B, right? or 6b you are saying?
Yes, I guess 6B I haven't done it yet. Yes, sir, this one, d dot a raised to power n minus 1, that
Huh?
highlighted one.
Okay, okay.
I have used this one.
Yeah, this part, right?
Yes, sir. I
You,
will use this for a dot b. Here we have done b dot a raised
yeah,
to power n minus 1,
huh.
and I have used a dot b power n minus 1 is equal to b raised to power n minus 1 into a raised to power n minus 1. Uh,
Okay. Actually, I am losing. You are saying line by line, but it is difficult for me to keep.
okay, sir. I will explain it. Dhire.
Yeah, yeah, it's fine.
Okay, sir.
But yeah, so okay, I will start doing it, and you follow that if you have done
Yes, sir.
in the same way or in a different way, and let me know.
Okay, okay, sir.
Okay, okay. So solution. So first we try to show this one, and for that okay, ab to the power n, we have that ab to the power n should be n dot b to the power n, and this implies that again from the previous argument ab equals to an bn, and this implies that if I just multiply a inverse to the both side,
Yes, sir.
uh, it should be a inverse an bn, should be a minus 1 bn, and should be b dot, this is n minus 1 times.
Yes, sir.
So we can simply rewrite this with the associative property, that is this b, this is to n minus 1 times, and this should imply that this. Now uh,
Sir, you are going in wrong direction
Yes, sir. Actually,
from this step.
but
Sir, you could have used that this n minus times will be ab to the power n minus 1.
okay,
So
uh, okay,
you
okay,
can use.
uh,
Hmm.
okay, give me 2 more minutes. Think yeah, yeah, there are several ways to prove this, but I have a pre-written one in my notebook, so I am just following that. uh,
okay, okay.
n minus 1 bn a, uh, because these classes are getting recorded and will be uploaded to YouTube. That is why we need to do some solution beforehand, so that we utilize uh, much of the time we are given. But anyway, I will listen to that. Let me finish this. So yeah, this will be n times. Uh, so we will be given that s to the power n should be an minus 1 bn a, and again from the convention it should be bn to the power n and n minus 1 bn a, and from there we can just simply write this n minus 1 bn. This is okay, right? And Akanksha and
Okay.
Sandeep, what you are saying that
I was saying there in the step BA into BA n minus 1 times.
okay, huh,
Yes, sir.
hmm.
So I have used AB into AB n minus 1 times, the above one step.
Okay, I get it, I get it. So okay, let me do
So
this.
she want to use the previous result.
Yeah, yeah, yeah. So from here you did this in minus 1, uh, b n minus 1 bn, and from here you used a n minus 1 b n minus 1 b, but this is identical,
No,
right?
no, sir, no, sir, no, sir.
Okay.
Uh, in the last step,
Sir,
where you
order
have
is changed,
written
sir.
the above step.
uh, from here we will be getting a n
No,
minus.
sir, you have taken wrong step.
Sir,
Okay.
you should have written b times ab to the power n minus 1.
Yes, sir. Uh,
Yes, sir.
step
Okay,
B.
okay, okay, I'm getting it now. Okay, sorry.
Yes, sir.
Oh, from the this thing, I think, na?
Yes, sir. Yes, sir. Yes, sir.
So it should be b to the power
AB
n
times and minus 1.
minus 1 bn b dot bn minus 1. Ah, right. This is much simpler. Thank you. Yeah.
Yes, sir, like that only.
This is much simpler. Yeah, this is nice actually. Okay, thank you. Okay, we should go to our next one. That is, and let me know if you again. Yeah, this is nice. Let me know again if you have done in another way. Uh, A B
So
A.
actually, we were focused on the first part only.
Okay, okay, it's fine. It would be difficult for me to also if I was in your places to do this simultaneously one after another. Okay, so this is given. We have to show that this is identity. A B A inverse B inverse. It should be n square, and A B A inverse B inverse. It is minus n, right? Then we are giving a n square b n square a minus n square b minus n square, and b okay, square.
So this part also need to be proved, na?
Sorry.
Sir, you have used that AB A inverse B inverse to the power n square is A to the power n square B to the power n square like.
Ha ha ha
So
ha.
this is also not proved.
Not proved
We
means
only know
uh,
we only know about n, but not about n square.
yeah, you are right. But so okay, let us do this for uh, two parts. That is a b n square should be a n square b n square. Then we will come back to this. Okay. Uh, so this means that we have ab to the power n uh, to the power n, I guess. So this is a n b n to the power n, and that means a n square b n square, right? Is it clear? I think it should be clear.
Yes, sir, it is clear.
Uh-huh. So once it follows for 2, then it follows for 4, right? Because you can just simply divide them as you like 2 plus 2 or 3 plus 1, any format. Then again you successively so yeah. And one thing to notice is that I have changed here this chronology here, that A inverse B inverse, from there I have come here to B A B inverse A inverse. That is because uh, A B inverse should be B inverse A inverse, right? So it is exactly I have written here. You should check that. uh, okay, and please tell me if something you find wrong, or you have any doubt. Okay, so now it will be a n square b n square, a minus n square b minus n square, b to the power n, a to the power n, b to the power minus n, uh, this, and then from here can go a n square. Okay, let's cancel out some terms. uh, uh, it should be a n square b n square, uh, a minus n square, uh, it is there, and b minus n square into b to the power n, and a to the power n, b to the power minus n, a to the power minus n. Now from here it should be a n square b n square minus n square, and it is b to the power mm, minus n to the power n minus 1, right? Yeah, minus n square plus n can be written like that, and n b minus n a minus n. So from here again you can write it as a n square b n square the power minus n minus 1 to minus n square a n b minus n a minus n. So the question is, how are we coming here uh, from the previous part? So I think it comes from this. That is this part. So what we have done is that a minus n square b minus n minus 1 equals to b minus n minus 1 to minus n square. Can anyone tell me why we are getting this, why these two are equal?
Which one?
This I have written in the right hand side. So
I think you want to use the first
yeah,
statement of this problem.
yeah, it actually follows from. So let me give this as an exercise. Uh, For until this, I had proven everything. So let actually follows from bn a minus 1 equals to n minus 1 bn. Just think and just post it in the community group, community mail, or it's better to be.
Okay.
Yeah, yeah.
Can you form a WhatsApp group, sir?
Sorry.
Can you form a WhatsApp group where we can ask questions?
Yeah, 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 I can. Okay, so somebody, if one of you create a WhatsApp, because I don't have your numbers. uh, this is my number. uh, so if one of you can do this
So,
tutorial.
to tell everybody to write down their number in the comment section.
Yeah,
I will perform. I will
yeah,
make a WhatsApp group.
yeah, yeah, thank you so much for that. So Sandeep has given his number, so this is mine. Okay, I will.
Answer the question A part. The way you have solved is more correct because we have done it in the question number 6, but in another situation, maybe we don't know about the question number 6, then we can't use the trick we have used here.
Yeah, yeah, yeah. See,
Yes.
these type of questions are not at all easy. Like sometimes they seem easy, but when you, because these are calculative and like uses your brain very much. So sometimes
But
you.
I think if someone is attempting first time, then it, he cannot attempt that question
Yeah, yeah, yeah.
in the given time.
But
He
the,
must be familiar beforehand.
yeah, yeah, yeah. This is very much true. So, but again, these are very important to practice, because this only using cancellation laws and this simply n a b to the power n equals to a n b n, uh, like you have less tool in your hand. So that is why this become very important in exams and everything. But yeah, let us finish this. So we have done till now this, that in square. Yeah, from here it follows that should be n square bn uh, minus n to the power n minus 1. Again it is coming from this. So bn minus b minus b to the power minus n, a to the power minus n, and again this would imply that a n square a minus n, using the same argument like this, uh, bn b minus n to a minus n, and again this should simply mean equals to e, and a n square minus n square plus n to a minus n, simply this should mean. So the only trick again, doing this part, this should I think this should follow from this part like this part. So I actually encourage you to do this, and if you akanksha form a group, just let everyone know if anyone of you do.
Okay, sir.
Okay, so I think we will stop here. And
One thing I want to like request,
yeah,
instead of doing calculative problems in this session, like why don't you like just sort of take each concept, each theorem that is covered in the week and give just 2 3 examples. That will give us more idea of the subject and what is covered. And because the notes and the lectures are not like, they are fairly abstract, right? Like you just give examples of theorems, maybe like the coset laws and how the cosets get divided, how the group gets divided, those sort of things we want. Like this calculative thing anyway we have to struggle, right? This will come with only with by
yeah, yeah,
practice.
yeah, yeah. I get your point, but uh, when we actually this was my previous this was my understanding also, but in the orientation for the TAs, they actually encourage us to do these kind of problems. They tell us to not to follow whatever the professors do in the classes, because they say that it will get monotonous, and because they are already hearing from the professor. So maybe the example things and what you just said, that maybe they can follow from the books, so better to
That
do.
is a problem, right? Like see, you are mathematical scholar, right? So you will have collected many examples of, say, for example, Lagrange's theorem or something like that, from many
Hmm,
many
hmm, hmm,
times you
hmm,
would have
hmm, hmm, hmm.
collected from like over, because but we are working professionals, or like we are part-time persons.
Yeah, yeah, yeah,
So,
yeah, I can
so
understand
like
your.
to get the idea of subject, like, right, idea is more important. I mean,
Yeah,
calculative
yeah,
work, everyone, it's just, yeah.
any day idea is far more important than this doing these problems. But yeah, okay, I will keep in mind what you just said, and I'll try to mix both of these things, like uh,
Sir, but problem solving sessions are organized to solve the assignment problems, to give
actually
some help.
they told us not to do the exact assignments. That way we'll be getting
Or something similar to assignment problems.
uh, I mean, see, the if I just change the numbers or change the notations or change, like actually this is a requirement from my coursework, so that I have to be very careful in what I do, because unless they will give me warning or something. But yeah, what you just said I will keep in mind, like uh, Shankaran and yeah, Sandeep. I will keep in mind what you just said, and I will try to fix these concerns in from the next
Sir,
classes.
I have no problem with your content, sir. Your questions are very good, sir.
Sorry. Uh,
Sir, your questions are very good, sir.
oh, this
They are
question.
different, sir. Yes, sir. These questions are very good for any competitive exam purpose, sir.
Uh,
Currently, I am preparing for, sir, CSIR net, so these are good questions.
yeah, I mean that was my aim, but it is also good to discuss some theoretical aspects, because sometimes we overlook them. But
Whether you can take a half an hour
nah,
earlier.
that would be
Yes.
nice. Yeah, just to I think it is okay, Shankaran, that if we just cover the theorems and examples for half an hour or 45
Yeah, yeah,
minutes.
exactly. That is all. That
Ha
is
ha
all.
ha ha ha. Yeah,
See,
yeah, yeah.
if I like most of the other guys, I understand they are like full-time student.
Ha ha ha
They
ha
are
ha.
very young, like in twenties. I am
Hmm.
like, I
Yeah,
am
yeah,
20
yeah.
years. Yeah, I just need some sort of, because if I attend the lectures, right?
Hmm, hmm,
So
hmm, hmm.
what happens is, I don't have the time to attend lectures. So
Yeah, yeah,
because I
yeah.
cannot sit for 6 hours, three
But
hours, and
I think without lectures, you cannot understand the subject. Within 2 hours, what can you expect from a teacher? I,
Uh, uh, Actually, Shankar, I would encourage you to, like, if see, if there are 5 or 6 lectures, like, let me open the syllabus. So
yes, sir, 5 and 6 lectures per
yeah,
week.
if you are familiar with, say, in week 2 there was group action, coset, group homomorphism, normal, subgroup. Yeah, etc. So if you are say if you are familiar with cosets, group homomorphism and normal subgroup, but you are not familiar with the dihedral or semi-direct product, then I would encourage you to like go to those lectures and like maybe speed it to 1.5 times, and then 30-minute lecture would be like 20 minute, or two times then it will be
Okay.
15 minute. Yeah, yeah. uh,
So what I'm thinking is that I have maybe I will get the textbook, maybe some Artin or something like that, and
yeah,
from
yeah,
that,
yeah, yeah.
like while travel to office, like I will just read it up. I was
Hmm.
hoping that like what I read from the textbook, like some example will be given in this sort of
Yeah, yeah.
session, right?
Artin is
And
very
some
good book.
representative
Yeah,
problems.
I encourage you to follow Artin. But it starts with I think a dihedral group and symmetric groups, those kind of things. Uh, those are very standard examples. But also you can like follow this one, this hash 10. This is much more in a friendly language, but they both are yeah, yeah, there are very very good books in the literature. So any standard good book will be enough whatever you
So
find.
like, but I must like, are you writing the notes for this? Like, because the notes are also excellent, actually. To be very honest, like they are brilliant, and sometimes little typos are there, but the notes are excellent. But the thing is that if I in week one I was able to solve full assignment only from the notes. So,
Yeah,
but
yeah, yeah.
week
See the
yeah.
professors they are giving lecture, Amritanshu Prasad and other guy I don't, Raghavan sir. So they are actually quite good lecturers and they write excellent notes. They are from both are from IMSC, and yeah, and I have I know them personally and I have attended some of the lectures. They are actually very good in what they do. So yeah, I think notes will be enough if you just follow that. You keep the book aside and follow the notes. I think that those will be enough.
Okay.
Yeah, yeah. And also these my note and uh, my note and my the this lecture will be in YouTube. So if you uh, utilize this time to read those notes and see my lectures later, that is also fine for me, whatever works for you.
Yeah, that is why I asked you to like sort of give like for maybe first 20 minutes, 30 minutes,
Ha ha ha.
just take each theorem and just maybe one diagram you can copy from some because you will have the experience, right? Like, oh, this theorem, the good example, the most illustrative example is this. Just
Yeah,
follow it
yeah,
that.
yeah. But yeah, yeah, yeah. I actually, yeah, I will try. I will try. Let's see. From next classes, I will see. Okay, okay. I think it is enough. It is enough for today. Okay, Yamini. Yeah. Oh, okay. You sent a message or something. No. Okay. Yeah, I have seen, but she's not saying anything. Okay.
Sir,
Yeah.
if you have some more problems, then you can post there in
In
group, sir.
WhatsApp group. Okay, I will try. I will try.
Yes,
I
sir.
will try. Uh,
Okay, sir. Thank you.
okay. Thank you. Thank you everyone for joining. This was a good session. Okay. Bye.